Okay, so the other thing we're going to talk about is the law of cosines. And this is actually much cooler, in my opinion, much cooler than the law of sines. In fact, I kind of wish that we could end class with the law of cosines, because that would really provide kind of a nice unity to the whole course. Because we started the course with the Pythagorean Theorem, and the Pythagorean Theorem we saw all over the place in this pre-calculus course. And the law of cosines is kind of like the ultimate Pythagorean Theorem. Okay. It's an extension of the Pythagorean Theorem. So it says the following, that if you have any triangle, right? So the Pythagorean Theorem only applies to right triangles. Law of cosines is like the Pythagorean Theorem, but for any triangle. So it says the following. Again, let's call the angles A, B, and C, capital A, B, and C, and let's call the lengths little a, b, and c. And so the law of cosine says the following, that c squared equals a squared plus b squared minus 2ab cosine c. Okay. For any triangle, you're always going to have this, you always have this relation. C squared, this is not really a hypotenuse, right? All of the side lengths are, equal, right? There is no hypotenuse here. But one side length squared is always the sum of the other two, the squares of the other two side lengths minus this term. Okay. And you see that if C were a 90-degree angle, what am I doing? Right? If C were a 90-degree angle, then C would be the hypotenuse, right? If C were a 90-degree angle, then this little c would be the hypotenuse. And what would the law of cosine say? It would say c squared equals a squared plus b squared minus 2ab cosine of 90. What's the cosine of 90? 0, right? It's the x-coordinate of this point on the circle, right? So it's 0. So the law of cosine says c squared equals a squared plus b squared if this angle is 90, right? So it encompasses, this thing encompasses the Pythagorean theorem, right? And in fact, it says a little bit more, because it says that the only way that this is going to be true is if the angle is 90, right? So it's kind of given you a reverse of the converse of the Pythagorean theorem, saying that if c squared equals a squared plus b squared, then this cosine must be 0, which means that the angle is 90. So you can, if you have a triangle and it satisfies c squared equals a squared plus b squared, you know it's a right triangle. Okay, so it's kind of like the opposite of the Pythagorean theorem. Right? Pythagorean theorem says if you've got a right triangle, then this happens, and this tells you if this happens, then it must be a right triangle. Okay, so yeah, remark gives a converse to Pythagorean theorem. Okay. It's just a side comment. Oh, I don't know if we're going to finish up. So we may have a little bit more at the, we'll see. Okay, so. Again, let's do the applications first, so that you can do your homework, and then we'll finish. We may have to go next time. Okay, so here's an example of the application, and the applications are all kind of not that interesting. They're all the same as before. Like you're given 3 parts of something, and find the 4th. So like here is x for 10, 150 degrees, right? And they say, what is x? Okay, so anybody see how to do it? What are we gonna do? right? What are we going to use as our C? We have only one angle here, right? So this is going to be that capital C, right? So Pythagorean theorem says x squared equals a squared plus b squared minus 2ab cosine of 150. Right? Cosine of 150 is negative root 3 over 2. Whoops, I should have written a and b here. 2 times 4 times 10 times negative root 3 over 2. Okay. I'm not going to work it out. We just multiply these things, right? So you get x squared is equal to 116 minus 40 root 3s. Plus 40 root 3s. And so x is going to be the square root of. Yes?
Isn't it 80 root 3s?
No, because they've got a root 3 over 2, and we've got a 2
Oh,
here.
okay, yeah.
Yeah, so those guys cancel, and we are left with 40 root 3s. Okay. Yeah. Okay, another example. So this was actually 20b from your book. This is 23. Another example. Again, can't read it. 130, 6, 3, 130 degrees, and this is x. Okay. Again, this is not the most exciting thing. Right? We have this one angle here, right? And so we know that the one opposite, right? We know that 6 squared is going to be a squared plus b squared minus 2a times b, 2 times 3 times x, times the cosine of 130. Okay. So we're going to get 36 equals 9 plus x squared minus 6x, 6 times the cosine of 130 times x. Okay, and so you end up with some quadratic equation, right? So you get x squared minus 6 cosine 130 degrees, x minus 27 is 0. And then use the quadratic formula on it, and there'll be 2 answers, but one of them will be fake. One of them will be negative, and so that won't work. But anyway, it's all kind of the same thing. Okay. I think we do have time to finish up what I wanted to say about the law of cosines. So as usual, the thing is, why should we believe it? So let's suppose that we have A, B, C like this, right? And Okay. So why should we believe? Why is c squared equals a squared plus b squared minus 2ab cosine c? Okay. And this is actually the way this works out is actually kind of cool, because it actually falls out of the Pythagorean theorem. So it's funny, it's like the Pythagorean theorem implies the super Pythagorean theorem, right? So knowing the Pythagorean theorem actually gives us the law of cosines, which is like a more powerful version of the Pythagorean theorem that includes the Pythagorean theorem, right? So they're actually equivalent to each other. Okay, so we don't have much time, so let me just show you how this works. This length is a, right? I'm gonna call this thing x. Okay, let's call this guy x, and then this guy is gonna be a minus x. Okay, and then we're just going to go, as usual, crazy with the Pythagorean theorem. Okay, we've gone crazy with the Pythagorean theorem before, and it's fitting to sort of end in this way. Okay, so what does the Pythagorean theorem say? It says that, let's look over here, it says that x squared plus h squared equals b squared. Right? What does the Pythagorean theorem say on this side? It says that a minus x squared plus h squared is equal to c squared. This squared plus this squared equals this squared. Right? Okay, well that's good, right? So that tells us that h squared equals b squared minus x squared. And also down here we see that h squared is equal to c squared minus a minus x squared. Right? Okay, so let's set those things equal to each other. Let's set those things equal to each other, right? B squared minus x squared equals c squared minus that thing squared. Well, that's a squared minus 2ax plus x squared. Right? So that tells me that c squared minus a squared plus 2ax minus x squared equals b squared minus x squared. Right? I just, subtracted this thing and flipped all the signs. Okay. Now we've got a negative x squared on the left and we've got a negative x squared on the right. So we can get rid of those guys, right? And what we're seeing is that, let's move this a squared to the other, let's add a squared to both sides, and we get a squared plus b squared. A squared plus b squared equals c squared plus 2ax. I'm going to move the 2ax to the other side also. Sorry. So I'm going to move this stuff all to the other side. So we get a squared plus b squared minus 2ax equals c squared. Right? And this angle here is C. Right? This angle here is C. Let's think about, what's the cosine of C? What's cosine of C? What's cosine of C? Melanie, I'm going to make you do it.
A minus x over C.
So you want to think over here with this right triangle here. So
X over B. X over B.
x over b, great, right? X over b, right? So that, what does that tell me? That tells me that x is b cosine c. Right? Let's put that back in over here. Right? We get a squared plus b squared minus 2ax is equal to c squared. The law of cosines. Okay, that's it for today. See you guys next time.